Hello and welcome to Pytechie. In today's video, we will explore how scatter plot, box plot, and stem and diff visualization work. A box plot, also known as a box and whisker plot, is a powerful tool to visualize the spread and skewness of data. Think of a box plot as a snapshot of your data distributions. It shows the minimum low quartile Q1, median Q2, upper quartile Q3, and the maximum values. If you see in a diagram, the box itself contains the middle 50% of data. The line inside the box is the median, the midpoint of data, and the whiskers extended to the smallest and largest value that are not outliers. Points beyond the whiskers, those are your outliers values and lies for from the rest. Box plots are amazing when you want to compare distribution across a multiple dataset. They are compact, easy to interpret, and they are highlighted outlier instantly. So you can see who had a wider spread of scores, which class has a higher median score, and whether anyone's score usually high or low. If you see in below diagram, if median shift toward the uh, right hand side, that we can say is left skewed. If median shift toward the right hand side in a box, then we can say it is a right skewed. And it is if it is middle of this box, then we can say there is a no skewed in data sets. Now let's see the example. Here we have a raw data. Then first we will calculate Q2, which is a median of whole data sets. So we'll take 71 plus 73 divided by 2. We have already saw these things in a interquartile range. So if you haven't watched my previous video, you can just go and watch. I will provide the video in description. Similarly, we can calculate a Q1, which is the median of the first half of values. And then we can calculate a Q3, which is the median of second half of values. Then we can calculate a interquartile range, which is nothing but a Q3 minus Q1. Then we can calculate a whisker extended's lower bounds and upper bounds. After calculating lower bound and upper bound, we'll get all the data set. If any data points that fall outside the lower bounds and upper bounds are considered as an outlier. So by this way, we can easily detect outlier in box plot. Now let's see scatter plot. A scatter plot is a graph that uses dots to represent a value for different variables. Think of it as a map for your data. Each dot shows the relationship between a pair of numbers. Suppose we have a data set like height versus weight. So first we will collect all those numerical data for different person, and based on the range we can plot the x-axis and y-axis. Then we can see where each points are lying. Based on that, we can easily analyze the trend and check what is the outlier in datasets and is there any cluster are making out. So this kind of analysis we can do by plotting a scatter plot. As one variable goes up, so does the other. That means it is a positive correlation between heights and weight. If one variable goes up and other goes down, that shows the negative correlation between the two data points. And if you don't see any clear relation, clear pattern between the dots, then we can say there is a no correlation between the. You can use a scatter plot when you are comparing the two numerical variables and looking for the relationships. It is an whether it is linear or non-linear. They are awesome for identifying a correlation between two variables, finding a pattern in experiments, spotting outlier, also the analyzing the customer behavior. So scatter plot give us a bird eye view of the relationship between two variables. If the dots move up and to the right, they are positively correlated. If they move down negatively, so if there is a no pattern count, that means there is no correlation. Now let's see stem and leaf plot. A stem and leaf plot is a simple chart that split numbers into two parts, a stem and a leaf. It helps you to see how data is spread out just like a histogram, but you will still get to see actual values. Now let's see the example. So stem is nothing but the all digit expect the last one, and leaf is the last digit. Suppose you have taken a number like 45, the 4 become the stem and 6 become the leaf. Now take another number like 46, then 4 is a stem and 6 become a leaf. So you can do this for all numbers and group them by stem. As you see in a plot, so 4 is a stem, 5 is a leaf, and 6 is a leaf. and then 5 is a stem, 1 is a leaf, 3 is a leaf, 4 is a leaf, 5 is like last digit of the every data point should be a leaf, and before that all the number it should be a stem. So by doing this, you can quickly find the median mode or even outlier from the data, and you don't lose the original number like you do in a bar chart. But always keep in mind, when you are using the stem and leaf plot, so it is will work well with the small and medium data size. If data size is used, then it create a messy diagram. Thanks for watching the video. We'll see you in next one.